Yes, we'll discuss example on curve tracing in the equation which is in a Cartesian form. So when the equation is in terms of x and y, we say that the equation is in Cartesian form. Now, see in this example, we have to trace the curve x into y square is equal to a square into this bracket a minus x. As we can see that this equation is in terms of x and y. This is the equation in Cartesian form. Now, first we'll check the symmetry of this curve. The given equation is x into y square is equal to a square into a minus x. So we can observe that there are only even powers of y in the equation. देखो equation में y square है. There is no term like y cube, y raised to 1. There is no odd power of y. We have only even power of y, that is y square. Power of y is 2. So there are only even powers of y in the given equation. There is no odd power of y in the equation. Therefore, the curve is symmetric about the x-axis. Remember, as per the rule, if there are only even powers of y in the given equation, then the curve is symmetric about the x-axis. So here this curve is symmetric about x-axis. Also note that this curve is not symmetric about the y-axis. See if there are any odd powers of x in the equation. Like you can see that there are two terms of x, and in both the terms power of x is 1, which is the odd power of x. If there are odd powers of x in the equation, the curve is not symmetric about the y-axis. So for curve to be symmetric about y-axis, we should have only even powers of x. Now there is no even power of x, or we can see that there are some odd powers of x. So the curve is not symmetric about the y-axis. We did not write where it is not symmetric, but we should write where it is symmetric. वो कहाँ symmetric है वो लिखना चाहिए, कहाँ symmetric नहीं है वो लिखना जरूरी नहीं है. Now to check whether the curve passes through the origin, curve origin से pass हो रही है या नहीं हो रही है वो check करना है. See, when the curve will pass through the origin, for some value of y if x becomes 0, or for some value of x if y becomes 0, then we can say that the curve passes through the origin. So to check this, if you consider the given equation, I open the bracket, this a square into a becomes a cube, a square into x becomes a square x. If in this equation if you put y 0, हम y को 0 पुट करेंगे और ये चेक करेंगे कि जब y 0 है तो x 0 होता है कि नहीं. We'll put y 0 and check whether x is becoming 0 or not. If I put y 0 in this equation, see x into 0 will be 0. This will be a cube minus a square x as it is. If I bring minus a square x on LHS, it will become plus a square x is a cube. So we get x is a cube upon a square, which becomes a. Therefore, x is a. So when we put y 0 in the given equation, we are getting x is a. So when y is 0, x is not equal to 0. Therefore, it means that the curve does not pass through the origin. जब x हमने 0 पुट किया या y को हमने 0 पुट किया, y को 0 पुट किया तो x 0 नहीं आया. So it means that the curve is not going to pass through the origin. Curve is not going to pass through origin. हमने देखा curve symmetric about x axis है, वो origin से pass नहीं हो रही है. Also to check whether the curve passes through the origin, we have one more rule. If you open the brackets, we can see that in the given equation, the equation it is x into y square is a cube minus a square x. After opening the bracket on right hand side, so there is a term of a cube. See, this is an absolute constant. A cube जो है वो absolute constant है. Means it is not multiplied with any variable like x or y. So if we have such a constant which is not multiplied by x or y by any other variable, we will call it as an absolute constant. And if there is an absolute constant in the given equation, then we say that the curve does not pass through the origin. जिस equation में कोई absolute constant होता है, एक ऐसा constant कि जिसको x या y का कोई टर्म, कोई वेरिएबल का टर्म मल्टीप्लाइड नहीं है, तो वो कर्व ओरिजिन से पास नहीं करेगा. सो द कर्व डज नॉट पास थ्रू द origin. And now since the curve does not pass through the origin, there is no question of finding tangent at origin. अगर कर्व ओरिजिन से पास होता है तो ही हम tangent at origin फाइंड करते हैं. ये जो अपना कर्व है वो ओरिजिन से पास नहीं हो रहा है, इसलिए हम tangent at origin नहीं फाइंड करेंगे. Then to find asymptote. Now what is asymptote? See, we know asymptote is a tangent to the curve at infinity. Asymptote is tangent to the curve at infinity. Or see, asymptote is a line which will run parallel to the asymptote. asymptote एक ऐसी लाइन है जिसको कर्व हमेशा पैरेलल रन करेगा, उसको कहीं टच नहीं करेगा. थ्योरेटिकली वो इंफिनिटी को टच करेगा. नाउ to find asymptote parallel to y axis, we have to equate the coefficient of highest degree term in y with 0. देखिए अगर हमें एसिम्पटोट पैरेलल टू y एक्सिस फाइंड करना है तो हमें करना क्या होता है, ये जो गिवन इक्वेशन में y का हाईएस्ट डिग्री टर्म है, गिवन इक्वेशन में y का जो हाईएस्ट डिग्री टर्म है, देखिए ये y का हाईएस्ट डिग्री टर्म है, हाईएस्ट डिग्री टर्म, एक ऐसा टर्म जिसमें y की डिग्री हाईएस्ट है वो है वाई स्क्वायर, उसका कोएफिशिएंट है x, उसे हमें इक्वल टू 0 करना है. So to find asymptote parallel to y, we have to equate the coefficient. We have to equate the coefficient of highest degree term in y. Highest degree term in y is y square. Coefficient of that is x. That we equated with 0. We got x is equal to 0, and we know x is 0 is nothing but the y-axis. X is 0 is the y-axis. So that is the asymptote to the curve. X is 0 is the asymptote to the curve. So we have found asymptote parallel to y-axis. To find asymptote parallel to y-axis, we equate the coefficient of highest degree term in y with 0. Similarly, we'll check if there is any asymptote parallel to x-axis. Now, to find asymptote parallel to x-axis, we have to equate the coefficient of highest degree term in x with 0. Given equation में एसिम्पटोट फाइंड करने के लिए, एसिम्पटोट पैरेलल टू x फाइंड करने के लिए हम क्या करेंगे, जो x की हाईएस्ट डिग्री टर्म है उसका कोएफिशिएंट इक्वल टू 0 करेंगे. अभी ये जो गिवन इक्वेशन था उसे मैंने एक्सपांड कर दिया फिर एक बार. इसमें देखिए कि x के दो टर्म्स है और दोनों में x का पावर सेम है, x raised to 1. तो हाईएस्ट डिग्री टर्म इन द गिवन इक्वेशन इज ऑफ x and that is x raised to 1, and in both the terms degree of x is 1. So we will bring the terms on one side. See, I brought all the terms on the left hand side, and from these two terms we can take x common. Now this is the highest degree term in x. ये x की highest degree term है. इसका coefficient क्या है? y square plus a square. See, the highest degree term in x is x itself. Coefficient of that is y square plus a square. We equate the coefficient of highest degree term in x with 0 to find asymptote parallel to x axis. y square plus a square is equal to 0 हो गया. Y square is minus a square हो गया. Y is equal to plus or minus root of minus a square हो गया. We are getting a minus sign inside the root. Minus sign inside the root means y is becoming imaginary. So that means, see, y is imaginary means there is no asymptote parallel to x-axis. Correct? So whenever you get minus sign inside root, it becomes imaginary, and if it is imaginary means therefore there is no asymptote parallel to x-axis. So we have asymptote parallel only to y-axis. So which was x is 0, or y-axis itself is asymptote parallel to the y-axis. That means the curve is going to run parallel to y-axis. We will see how. Then to find region of absence, हमें region of absence find करना है. तो देखो, to find region of absence means the region where the curve is not present. हमें वो region find करना है जहाँ curve present नहीं है. तो automatically वो region भी मिल जाएगा कि जहाँ curve present है. Once we find region of absence, the region where the curve is not present, automatically we'll get the region where the curve is present. If you consider this equation, x into y square is equal to a square into a minus x. Solving this, we'll get y square is equal to a square into a minus x upon x. Now, if you divide this region into three parts, now see how I got these three parts. See, the given equation I've rearranged. I've kept y square on the left hand side. Y square left hand side में है और बाकी के सारे terms right hand side में लेकर आया हूँ मैं. I brought the equation in the form y square is f of x. So see, to find the region of absence, we should express the equation in such a way that you should bring y square term on the left hand side and the remaining terms of x on right hand side. Or you can do vice versa. We can bring x square term on left hand side and all terms of y on the right hand side. But here in this case, we can bring y square on left hand side and the terms of x on the right hand side. Now observe carefully, for what values of x, either the numerator or denominator of this equation becomes 0. You can observe that denominator of this equation becomes 0 when x is 0. Remember, x is 0 is nothing but y-axis. I have drawn this line y-axis, that is x is 0. Then I can see that the numerator becomes 0 when x is a. If I put x is equal to a, this a minus a becomes 0. The numerator becomes 0 or x is a. So I have drawn this another line x is a, which is a line parallel to x is 0. Remember, x is a, x is 2a, etc. They are lines parallel to x is 0. But here we can see that we have drawn only two lines, x is 0 and x is a. We have drawn x is 0 because we can see this denominator of this equation becomes 0 when we put x is 0. I have drawn this line x is a because I can see that this numerator becomes 0 when x is a. So we have drawn these two lines. Now what is the use of drawing these two lines? See, these two lines divide this given region into three parts. Which three parts? X less than a. See, so I should say it is x less than 0. It is not x less than a. It is x less than 0. Three parts. First part is x less than 0. Second part is x between 0 to a, and then x more than a. X less than 0 means what? See, on the left hand side of x is 0. X is less than 0. X is negative. So x can be minus a, minus 2a, minus 3a, minus 4a, minus infinity. So x less than 0 means all negative values of x, like minus a, minus 2a till say minus infinity. Then the second region we get is x between 0 to a. Between 0 to a, it can be 0.1 into a, 0.2a, 0.3a, 0.4a. For example, I have considered x is 0.5a. And then x more than a. X more than a means it can be x is 2a, x is 3a, till x is infinity. Here I have considered x is 2a. See, what we have to do is, we have to check in this region where y square is positive or where y square is negative. If for some value of x, y square is positive, then it means that it is region of absence. See, listen this carefully, this is important. The region where y square is positive for any value of x, that region will be considered region of presence. There the curve will be present. Whereas the region where y square becomes negative for any value of x is the region of absence. जिस region में x के किसी वैल्यू के लिए y स्क्वायर नेगेटिव होता है वो रीजन ऑफ एब्सेंस होता है, और x के किसी वैल्यू के लिए अगर y स्क्वायर पॉजिटिव है किसी रीजन में तो वो रीजन ऑफ प्रेजेंस होता है, मतलब वहां कर्व प्रेजेंट होगी. नाउ we'll check this. This can be done orally also, but I'm showing this in detail so that you can understand it properly. See, for the first region x less than 0, so I should take this as x less than 0. It is x less than 0. For x less than 0, if you consider the first region x less than 0, I am considering the value x is minus a. You can assume any negative value of x like minus a, minus 2, etc. I have taken x is minus a, and that I am going to substitute in this equation. I want to check whether y square will be positive or y square will be negative. हम x is minus a इस इक्वेशन में पुट करेंगे और ये चेक करेंगे कि y स्क्वायर पॉजिटिव आता है कि नेगेटिव आता है. अगर y स्क्वायर पॉजिटिव आता है तो वो रीजन ऑफ प्रेजेंस है, y स्क्वायर नेगेटिव आता है तो वो रीजन ऑफ एब्सेंस है. We put x is minus a in this equation. We get y square is a square into bracket a minus of minus a divided by minus a. जहाँ x था वहाँ हमने minus a पुट किया for the region x less than 0. If you solve that, this minus of minus will become plus a will become 2a. It will become a square into 2a upon this minus a. When a gets cancelled, we get this as minus 2a square. We are interested in checking whether y square is positive or negative. By substituting x is minus a, which is a value which is less than 0, see that y square is positive. So y square is positive in this region, x is less than a. X is less than 0. It should be y square is positive in the region x less than 0. So therefore y square is negative in that region x less than 0. So it is a region of absence. That means the curve is not going to exist in this region. It is a region of absence, ROA. Why? Because there we can see that y square becomes negative. Y square is negative, so it is a region of absence. Similarly, if you consider case 2, for the region 0 to a, x lying between 0 to a, we can have values of x like 0.1a, 0.2a, 0.3a. I have chosen some simple value like x is 0.5a. With this value, we want to check whether if you put x is 0.5a in this equation, whether it becomes positive or it becomes negative. If I put x is 0.5a here in this equation, this becomes a square into a minus 0.5a upon, in place of x, I am substituting 0.5a. So you'll find that 0.5 is going to get cancelled. 0.5 gets cancelled and a gets cancelled. Here it becomes, when a gets cancelled, it becomes, what we get is a square. See, what we are interested in whether it is positive or negative. We can see that if you put x is 0.5a, this equation, we are getting y square as positive. Y square is positive in that region 0 to a. So therefore it is a region of presence. Here in this region 0 to a, x is 0 to x is a, the curve is going to exist. Now we'll check for the region x more than a, x is greater than a. We can choose any value of x which is more than a, like x is 2a, x is 3a. For timing I am taking x is 2a. We'll put x is 2a in this equation here, and we just have to check whether y square is positive or negative. Y square is positive, it is region of presence. Otherwise it will be region of absence. So see, in place of x I substitute x is 2a, and substituting x is 2a, I can see that this a minus 2 will be minus a, this bracket will be negative, denominator is positive. You can see that is negative upon positive, so it will be negative. Y square is negative. See, we are not interested in the magnitude, but we are interested in the sign, whether it is positive or negative. We can see that y square is negative in that region, x more than a. So therefore we can say it is a region of absence. The curve is not going to exist in that region. So we have found out region of absence. Now, so see, we checked for symmetry, we checked whether the curve passes through origin. Since curve is not passing through origin, so we didn't find out tangent at origin. We found out asymptotes. We found out that x is 0, that is y-axis is asymptote to the curve. Now we found out the region of absence. Now we'll check if there is any special point. See, we know that the curve does not pass through the origin. You can see that if I put x is a in this equation, this a minus a becomes 0. We get y square is 0. We are getting y 0. Given equation में अगर हमने x को a put किया तो a minus a 0 हो जाता है. We get a into y square is equal to 0. So we get y square is 0. So when x is a, y is 0. So that is a special point. Why it is a special point? See, a comma 0 lies on x axis. See, any point which lies on x or y axis or any axis of symmetry is a special point for us. That is a special point. At special point, we always find what is dy by dx, because from dy by dx we come to know the nature of the tangent. जो भी स्पेशल पॉइंट है वहां पर हम dy by dx फाइंड करते हैं, क्योंकि tangent से हमको कर्व का नेचर पता चलता है कि कर्व कैसे टर्न करने वाली है, ये पता चलता है. For that we'll differentiate this. We can differentiate directly. What I've done, I've expanded this bracket. So I got x into y square is a cube minus a square x. If you differentiate this equation with respect to x, for this term x into y square, I'm applying product rule, u into v का formula apply करेंगे. First we keep x as it is. Derivative of y square is 2y into dy by dx plus this y square as it is, derivative of x with respect to x is 1, and that is now equal to derivative of a cube, derivative of constant is 0, minus derivative of a square into x. See, a square is constant, we take it outside, derivative of x is 1. So if we simplify this, we get 2x dy by dx is minus a square minus y square. I took this plus y square on RHS. I got dy by dx is minus a square minus y square upon 2xy. We have got the value of dy by dx. See, why we have found out dy by dx? Because we want to find what is the value of dy by dx at this point a comma 0. X is a, y is 0. For that, if you in this dy by dx, if you put x is a, y is 0, in place of x we'll put a, in place of y we'll put 0. We get it as minus a square upon 0, which is infinity. If we get 0 in the denominator, means it's infinite, it's not defined. So dy by dx at the point a comma 0 is infinity. Therefore the tangent at that point must be parallel to y axis. Remember, if dy by dx is 0 at some point, tangent is parallel to x axis. If dy by dx is infinity at some point, it means that the tangent is parallel to y axis. Here it is infinity, tangent is parallel to the y axis. Now see what all we have seen for this curve. We have seen that the curve is symmetric about the x axis. See, I have drawn the x axis, y axis. We know that the curve is symmetric about x axis. We know that the curve does not pass through the origin. We have seen that x is 0 is the asymptote to the curve. That means the curve is going to run parallel to the y axis. We know that this point a comma 0 is a special point. The curve is going to pass through that point. Also we know that at that point dy by dx is infinity. That means the tangent at this point is, say, parallel to y axis. That means x is equal to a itself is the tangent to the curve. So the tangent at this point has to be parallel to y axis. And we have found out region of absence. We know that the curve does not exist for x less than 0. We know that the curve does not exist for x more than a. Whatever is the curve is going to lie within these two lines, between the y axis, which is x is 0, and between x is equal to a. So if you draw the curve, see, we have to draw the curve in such a way that the curve is symmetric about x axis. Whatever is the nature of the curve above x axis, same will be the nature of the curve below x-axis. And this line x is 0 is asymptote to the curve. That means curve will run parallel to that line, and the curve passes through the point a comma 0. See, first of all, if I draw it here, I'm drawing it in such a way that the line x is 0 is asymptote to the curve. That means it runs parallel to that line. The curve is going to pass through the point a comma 0 in such a way that here dy by dx is infinity. That means the curve takes a turn in such a way that tangent at that point is parallel to the y-axis. And we know that the curve is symmetric about x-axis. So whatever is the nature of the curve above x-axis, same will be nature of the curve below x-axis. We are drawing approximate curve. We are not measuring any distance. Approximately we draw it. We draw it in such a way that this line y-axis, that is x is 0, is asymptote to the curve. Curve is symmetric about x-axis. Whatever is the nature of the curve above x-axis, same is the nature below x-axis. Or the nature of the curve below x-axis is mirror of image of the curve above x-axis. The curve passes through the point a comma 0, and here at this point tangent is parallel to the y-axis. So this is how we are going to get this curve. We draw the curve approximately. I hope you have followed this.